All right. Welcome to United Astronomy Clubs of New Jersey. Once again, we are in our winter season where we are in online only programs. I want to welcome everyone who has joined us here so far. Uh, do check us out on our website, uacnj.org. It's where you're going to find a list of all our member clubs, as well as information on our upcoming programs we have available. I know a few of you are probably wondering, hey, what's going on? Why aren't you doing programs every week? And I just wanted to let you know that we use this time during the winter when we don't have presentations every Saturday on the site to actually help do some upkeep and upgrades to what we can. And speaking of that upkeep and upgrades, everything you guys have done from liking and subscribing here on YouTube or Twitch, as well as the donations you guys have done have helped to further that goal because we are a nonprofit organization. Uh, with that, also you can also check out our social media pages, our Facebook, our Instagram. We got a Discord channel. Always happy to see new faces. Post your questions in there. Uh, like I said, we do live stream this on YouTube and Twitch, so always hop in, press those like and subscribe buttons. Now, uh, for tonight's program, our long running series, What's Up in the December Sky, with Lonny Buinis. Lonny has been giving the What's Up series since UACNJ opened in 1994. He received degrees from Stevens Institute of Technology in physics and computer science, then learned space art, animation, and video on his own. Lonny is the only member of IAAA.org who specializes in virtual reality worlds. He wrote the first interactive space history ebook and is most pleased to have married Jen, his narrator. And with that, here's Lonny.
Minutes ago, the planet Jupiter, closest point to Earth, still very far away, 5 astronomical units, 5 times the distance of Earth from the Sun, which is about 500 million miles. Minus 100 is 400, and then divide by the speed of light, and you can do the math. That's 35 minutes away. Right here, up here, the most distant thing in the universe that we've seen before in other What's Up talks from earlier in the year, the Andromeda Galaxy. Light left from there 2.5 million years ago. And right there in the middle, next to the triangle-shaped group of stars that goes by the unimaginative name Triangulum, the triangle is the Triangulum Galaxy, 2.75 million light years away, smaller than Andromeda, smaller than the one that we live in, the Milky Way. So that's just some of the things that we can see in the December sky. I'm going to start things off with onthisday.com, which tells us things that happened in all kinds of walks of life, but I search on space and astronomy. The first soft landing on Mars, the first successful and partially successful landing on Mars was a Russian probe, the space probe Mars 3. Mars has something called the Mars curse. Out of the 27 missions to land on Mars, 6 never made it. It's called the Mars curse. This was the first victim. It got there, it successfully landed. It showed a picture, a featureless gray blobby picture. And then after 110 seconds, it's about a minute and a half less, it failed. And that was that for Mars 3, which is down here below the great volcanoes, the big Tarsus region with Olympus Mons, the solar system's biggest volcano. Right down there, that's where you find Mars 3 today. Maybe someday somebody will go and collect that and sell the thing as a souvenir for lots of money to a museum. Who knows? On December 19th, for later on in this month, was the first radio broadcast from space by President Eisenhower. Our Christmas message. How appropriate. It's getting close to Christmas. So what's happening in the sky in December? I go to go-astronomy.com. I'll remind you about that later. And I look at the main events. And every month we have two phases of the moon. One is horrible, absolutely horrible for seeing faint objects like gas clouds, which are called nebulae, plural, nebula, singular. And one is terrific for seeing faint objects like star clusters. You can see planets almost anytime, even with all the light pollution that we have. But the new moon is great. The full moon, not so good for seeing details of faint objects in the sky. You can get an idea of what the phases of the moon are doing every month at moongiant.com. I'm going to advertise a few websites during my talk. I don't work for any of these companies. I'm an amateur astronomer, which means I do this for love, not money. So a lot of amateur astronomers are poor, but they love what they do. And you can ask them all kinds of questions when you come to visit, when we're open live April through October, when UACNJ is not so cold. And then you can ask all kinds of questions. There's no such thing as a dumb question. So check out a good time to see details on the moon when there's shadows showing up craters would be the first quarter phase at night as the sun sets. Look right in the south. If you like to get up at 5 in the morning, you can look at the last quarter moon on December 5th, which is only 3 days away. If you want to see faint objects at night, you look for the new moon, you won't see it anywhere in the night sky. It's in the daytime sky in early December, December 12th, and the full moon toward the end of the month. The only thing good about the full moon in a telescope is down here, not in this picture, but in real shots of the moon, you'll see the rays of Tycho. Tycho, very bright crater, big rays, ejecta, a material ejected when the asteroid that made Tycho exploded on the moon. Here's what December 27th looks like simulated in a free program that we'll use later on to simulate the sky. Not too good with the full moon out, right? Full moon blots everything out. You can still see Castor and Pollux from Gemini. Anybody know what constellation Gemini represents? It's a sign of the zodiac. And Orion, who's that? Most easily recognized constellation in winter. And by constellation, I mean not just any old star picture that you can make up. I mean, it's one of 88 that were recognized in the year 1930 by the International Astronomical Union. So I can barely recognize the belt of Orion. I can't see his sword at all. This is terrible. The full moon is a nuisance for seeing faint things or a clear sky. And then on December 12th, if you're looking for the new moon, you have to look in the daytime. This is in the morning at 11:53. The actual new moon phase, when it's closest past the sun, doesn't happen until hours later. But I picked a time when you could see the moon in the daytime from New Jersey. The other side of the world, they'll see at 10 o'clock at night, closest to the sun. Well, they won't see it, not at night, but they will. If you could find the moon in the daytime, that's where it would be on December 12th. New moon. Is part of the moon still lit up? What about the far side of the moon that we never see? Because the moon always faces us one direction. It's synchronous rotation. All the main moons of the solar system do this to their parent planet. Over time, tidal forces slow the rotation of the moons so that eventually they're locked. So they're always facing one direction to us. The other side is lit up. We just can't see it from Earth. Nice summary of all this is at moongiant.com. Again, you can get their calendar for each month. So a good time to see shadows and craters and mountains on the moon at 5 in the morning. if you like getting up that early, 6 in the morning. Just as the sun is rising, you'll see the moon in the south. Or if you want to do it at night, as the sun sets on the 19th instead. Great time to view a clear sky, the 12th of December. Other things are happening. Oh, you can turn on other information in moongiant.com, like the names of the phases of the moon. For instance, right now, today is Saturday, the 2nd. Do you know the name of this phase? I think of it as related to a name for a kind of ape, not a chimpanzee, not a gorilla. What do you think about that? In December, as in every month, the full moon has special names. And some of these go back to Native Americans. Some go back to, a reference by someone named Beard, summarize things that were used by scouts: deer mating moon, fur pelts moon, beaver moon from the Farmer's Almanac. And some of these are rather informal. Some come from Native Americans and some don't. And these make sense, right? Frosty moon, December, Burr, dark moon. I got these from Wikipedia, full moon names. There are also names for the new moon. Did you know? I just found out about that recently, and I've been around a long time. I got started when I was 10 years old looking through someone else's telescope at the moon. And I've been hooked on planets and astronomy ever since. That's what IAAA means. If I go back to my first picture, I absolutely adore astronomy. No, actually that stands for the International Association of Astronomical Artists. I am one of those. How about the end of the month, something very significant happens, the solstice. Sol, S-O-L, is the Latin name for our sun. Stice, stitial, means standing still or a moment in time. Solstice is when the sun is either highest in the sky or lowest. In December, what is it? It's cold, right? So at 3:21 Universal Time in London, at the Greenwich Observatory, subtract 5 hours from 3. Oh boy, that's tough going backwards. Well, 3 plus 12 is 15. 15 minus 5 is 10 o'clock at night. The day before, on December 21st, our time, 10:21, we would see, this is in the daytime, and that's pretty close. If you drew the orbit of the Earth around the sun, it might look like this, projected into the sky. And if you drew the Earth's equator projected into the sky, look how far below the Earth's equator the sun is. In summer, it's up 23.44 degrees. In winter, it's down 23.44 degrees. So the sun is only 40 minus 24 degrees above the horizon. It's low even at the middle of the day. This again is a screen capture from Stellarium, which is free software that we'll use in just a moment to look at the sky. But before we do that, I want to just mention two more events, or two groups of events. There's a planet that we hardly ever see, Mercury, innermost planet to the sun. December 4th is a great time. That's only 2 days from now. To hope the sky is clear. Keep trying around that time, even if it isn't. Its greatest distance away from the sun, elongation, that's an angle, not a distance, to the east. So where should we look? If you're facing south, the sun sets in the west to your right. East is which way? Left. So that means you would look at sunset. Sun setting in the west, look eastern elongation, 21 degrees for the planet Mercury. The elusive planet Mercury orbits the sun like this, back and forth, back and forth. And so it's a morning star or an evening star, just like Venus, the two inner planets orbiting closer to the sun than Earth. And here I'm looking at it on December 4th at 16 minus 12. Anybody good at arithmetic? 4:02 in the afternoon. The sun is setting, still up. It'll still be pretty bright, very hard to see. You want to look shortly after the sun sets, as soon as it gets dark enough to see the planet Mercury, which will be fairly bright, like a bright star. Magnitude minus, what does that mean, a minus magnitude? Well, the faintest stars we can see, it's a logarithmic scale where each step is multiplied, not added, more than 2.5 times each step. Or every 5 steps is 100 times brighter. So compare 5, which is a magnitude we can see pretty much a limit in New Jersey skies that are not dark. 0 would be 100 times brighter. So Mercury is pretty bright compared to the faintest stars we can see on December 4th. And that's what the phase of Mercury looks like. It's like our moon phase now, which is, did anybody get it? Gibbous, not gibbon, like the apes, gibbous moon. Would you see Mercury like this in a small telescope? No. You can never see details this sharp. Mercury is small, it's far away, the air makes everything fuzzy on Earth. That's why we have space telescopes and robots. Finally, before we look at the sky, the last things I'll talk about are 2 meteor showers this month. If you missed the big bright one in August, the Perseids, try to look for the Geminids. And you do have more than just one night. The peak is December 13th into the 14th, best time after midnight. Let's start with the Ursids, which happen about a week later. There is a range of dates to see any meteor shower, but they start small, they start fewer, they can become more and then fewer again. So there is a peak time to do it. That's because we're passing through the debris stream of an old comet. And the meteors will streak out from the sky near, what's this? 1, 2, 3, 4, 5, 6, 7 stars, very famous. It's a small version of Ursa Major, the Big Dipper. This is the Little Dipper, or Ursa, Bear, Minor, Small. This is the Bear Small. And right there is where the meteors come from, in all directions, streaking out from the radiant point. Fairly quick, 100 times the speed of sound. So they go through the atmosphere in seconds and they burn up. How big are they? Huge, the size of cantaloupes. Oh no, cantaloupe, there's some contamination there lately. The size of watermelons, right? Nope. Golf balls? Nope. Peas? No. Sand grains. Tiny, most of them. Good thing for us. So it's a low rate in the shower, only about 10 an hour. They're going to streak out in all directions from that radiant point by Kokab, Beta Ursa Minor, second brightest star. There's Alpha, famous star Polaris, near the Earth's North Pole. See how close that is? Very close. The Earth's North Pole points in the sky, very close to this bright star. It won't always. And they go out in all directions. So what kind of special equipment can you use to see this debris field from Comet Tuttle? Your eyes. Don't need binoculars, don't need telescope. You do need specialized equipment, a lawn chair. You don't need bug spray, generally in December, as you would in August for the Perseids. But if you forget anything else I tell you about meteors this month, remember the Geminids radiating out near Castor in the Twins Gemini. I pointed this constellation out earlier when the moon was full nearby, full moon, the end of the month, the 27th. This will be very hard to see. But the Geminids, you have a nice spread of dates here. You have a chance to see them between early to late December. Best time, again, the middle of the month, the 14th. And you want to go out close to midnight if you can. If you can't, don't worry. Around midnight, you're looking down the Earth's shadow into space, so it's nice and clear. But never fear, I've seen a good meteors even 9 o'clock at night, 8 o'clock. Keep trying. And don't give up if it's a little cloudy or hazy one night. Try again. I have to warn you, in our area in the area where most of us live, I live in Bergen County. There's a lot of light pollution from street lights and industries, headlights from cars. I'm not going to see 120 per hour or one or two every minute. I might see one or two bright ones for a whole hour. But if you can get to a dark site like Jenny Jump, like UACNJ, which I have to warn you is closed to the public November through March, find a nice dark site if you can, or a nice open field. These meteors, even though they're streaking in at 35 kilometers a second, divide that by 1.6 for miles, mathematicians, or multiply by 0.6. They're considered slow moving, which means they make trails. So it's easier to find them, easier to see if the trails last longer. This is an unusual shower. It's not from a comet. There are only two known meteor showers that come from something that's not a comet. This comes from an asteroid 3200 Phaethon with a rock comet orbit. Comet that prefers rock and roll music. Right? You don't have to believe everything I tell you tonight. With that, I'd like to switch over to a simulation of the sky in a program called Stellarium, which is free to download and install on a computer like this laptop, or you can use their supercomputers on their website, or you can download the mobile version free for your mobile iPad or tablet or phone. So I'm looking in the north. I can do things I can't do on a star chart. Star chart like the one that we sell, shameless plug, warning, warning, shameless plug, we sell planispheres like this that show the sky as a circular chart with lines to help you identify constellations. You can you can set it to any date, any time of day or night to see what the sky looks like. I'm going to make things a little harder, though. In a computer program, I can turn things off and on. I can zoom way in to see that the Big Dipper is enormous in the real sky, pretty big. And it doesn't have 7 stars like the Little Dipper. It has 1, 2, 3, 4, 5, 6, 7, 8. Right? Many people don't realize there is a famous visual double star in the bend of the handle, Mizar and Alcor. Not related. Note the distance to these stars in light years from Earth. 78 light years for Mizar. Alcor is 82. So they're not bound by gravity. They're not a real double star. What do I mean by real? I mean an actual double star in which they orbit one another. Mizar itself is a double star, a real double star. Well, I shouldn't use the word real, but I'm going to be improvising a lot while I talk tonight. We can use a technique we amateur astronomers love to call star hopping if we take the Big Dipper's pointer stars, Merak and Dubhe, and go 5 times their distance apart, which is about 5 degrees of angle, which is about what your fist makes if you hold it out at arm's length. No matter how tall or short you are, generally that's roughly, that was a meteor, see it? That's roughly 5 degrees, so 5, 10, 15, 20, 25 brings us to, look at that, it's pretty close. The North Pole, which is right about where my arrow is, right near the North Pole, Polaris, the pole star. Polaris, Alpha Ursa Minor. The Greek letters, we use Greek letters for the brightest stars, alpha, beta, gamma, etc. And the brighter stars also have Arabic names from about 1,000 years ago. We still use those names for all the brighter stars like Merak and Dubhe and Kokab and Polaris. So what's this? Recognize it without the lines? It's a little harder. Big Dipper, Little Dipper are great and small bears. A long constellation snaking between the Big and Little Dippers. See the head? Oh, here it is. Head, body, Even I have trouble after many years. And the king and queen are up there too. See the letter M spells Massiopeia. Nope, Cassiopeia is the queen, and her husband, the king, kind of hard to see. Oh, let's cheat a little bit. Kind of looks like a house, letter W or M, depending on the time of the year. These are circumpolar stars, that never rise or set. Why? Because as the night wears on, they just circle the pole. They're close enough in angle to the pole that we can always see them, right? Always, right? Always, is that right? How about in the daytime? Can you see them? No. How about if I reset that to the current time? Back to now. Circumpolar stars. So now you know 5 circumpolar constellations: Big Dipper, Great Bear, Small Bear, Little Dipper, Dragon, Draco, Cassiopeia, Queen, Cepheus, the King. And I'm going to make things a little more difficult by turning off the circle. So if I want to get my bearings in the sky, I know where north is. So if I want to find west, where things are setting, I just look for the letter W, right? Go outside tonight, look for no. I can turn on cardinal points. I can turn them off. I'm going to leave them on in this computer program. And I'm going to look toward the west to see a star, a constellation of spring and summer, sorry. It looks like a cross or a swan, Cygnus the swan. One of my favorites for the summer for its beautiful double star Alberio, which I talked about earlier. You can see its bright star Deneb, the tail. This is often called the Christmas cross during this time of the year when Cygnus lies low on the horizon. And the bright star Vega, that will someday be our North Pole star. Someday soon, yeah, about 10,000 AD. So if you want to see those, you have to look quickly toward the west. Look low in the southwest and you'll see a star that doesn't twinkle. It's not a star at all. That's the planet Saturn. And it is amongst the stars of, what's this? Looks just like a guy carrying water, right? There's the water falling. There's the arm that, I don't know. What do you think? The water carrier, Aquarius. Saturn is in the stars of Aquarius. Does that mean it's close to them? Nope. Saturn is about an hour, light time, an hour and 21 minutes away. And let's pick a star at random in Aquarius. 500 light years away. Took light that long. When you look in the night sky at different objects, you're looking into the past different amounts of time. We're seeing Saturn as it was 1 1/3 hours ago. We're seeing Jupiter as it was 35 minutes ago. We see this star as it was 523.5 years ago. We see the Andromeda Galaxy as it was 2.5 million years ago. But galaxies evolve slowly. Our Milky Way is 10 billion years old. That's 10,000 million. Compare 10,000 million to 2.5. So you see that's not very much time for a galaxy at all. So we see the Andromeda Galaxy as it was to us long ago, but in the life of the galaxy, that wasn't long at all. Aquarius. Look up higher in the west, southwest. There's Jupiter. There's a great square, which is ironically enough called what? The Great Square, right? It's a very large constellation. I have to do this. I have to actually move my head side to side to see the whole thing in the real sky. In Stellarium, we can change the scale and move it down, make it smaller, and see the flying horse. There's the head, feet, body. What happened to the rest? Gone. Pegasus. Pegasus got taken over by Andromeda, the princess, with the Andromeda Galaxy. The Triangulum Galaxy I mentioned earlier, when we're facing south, tonight that's pretty high in the sky. We can zoom in and see pictures people took of these deep sky objects. This is a galaxy somewhat similar to ours. Our Milky Way has a bar down the middle, so it's called a barred spiral. This is a spiral galaxy with spiral arms of stars seen at an angle. Galaxies are fairly flat and thin, like dinner plates. But if they're tipped to us, like Andromeda or this one, that's what they look like. And that's what our galaxy looks like if you were to go to the Triangulum Galaxy or the Andromeda Galaxy. This is pretty much what our galaxy would look like with our two Magellanic Clouds seen from Andromeda. But what you want to do any time of the year, any time that you go out, if let's say we go out around 8 or 9 o'clock when everybody's still awake, right? Or if you come to any of my What's Up in the Sky talks, I'm going to end looking over with an overview of the sky, looking in the south. I'm going to look up higher for a place where in Pisces, the fishes, where the planets Jupiter and Saturn met 3 times in an amazing triple conjunction in the year 7 BC. Might have been a very good candidate for the Star of Bethlehem, predicted years in advance by the Magi, who were literally astrologer and magicians. But that's a topic for another talk. Maybe I can do that separately, or I'll mention it again in What's Up in January. Jupiter is right there, close to where it was 2,000 years ago. Pisces, the fishes, are near the Great Square. We have some of the stars of winter coming up. Here's the sea serpent that tried to eat Andromeda, who was chained to the rocks, poor princess, because her mother, Cassiopeia, boasted that Andromeda was more beautiful than any of the ancient Greek goddesses, including Hera, the wife of Jupiter. And that, as you know from your Greek mythology, that's the worst mistake, the absolute worst mistake you could possibly make, is saying that someone's more beautiful than Hera. And so the whole story was written out there. It's been in the library for 3,000 years. If you don't feel like reading, you can see the movies Clash of the Titan, old version and new. So what does Jupiter look like? Not like a star, certainly. Stars twinkle because they're activating a minimum number of cones in your eye, the cells that give color, or the rods that show black and white. Jupiter is a disk, so it activates more. And generally, planets, when they're high, don't twinkle. In a small telescope, like Galileo's 400 years ago, he could see that Jupiter had a disk and it was flattened. We now know Jupiter spins so fast that centrifugal acceleration pushes the equatorial part of Jupiter outward. It squashes Jupiter, to use a colloquial term. And if I were to put Jupiter in a telescope that didn't have a clock drive on it, something would make it move out of the eyepiece view. What? This is the rotation of the Earth that we're seeing in real time. Yep. The whole sky rotates. The Earth rotates around 360 degrees per day. Divide 360 by 24 and you get 15 degrees per hour. Right? A field of view of a telescope is generally very narrow, less than a degree. The size of the full moon is a half degree. But I can freeze it in stellarium. I can zoom in a little. I can see more detail in a bigger telescope. Some cloud bands. I can see the 4 main satellites of Jupiter, the Galileans, discovered by Galileo. You saw them shuttling back and forth like beads on a wire, like jewels on a necklace, back and forth. And there's my favorite, Europa, which may be the first place we should look in our solar system for advanced life outside of the Earth, independently evolved. Europa has warm water, oceans of it, underneath its icy, frozen surface. Oh, I'm looking at Ganymede, sorry. Where's Europa? Right there. Smallest but brightest of the four. Smallest and brightest, covered with bright ice. We're sending a mission there to drill down and see if some microbes may have percolated up. But we think that underneath the ocean, at the surface, there may be mid-oceanic ridges like the ones at Earth that have 800-degree smokers spewing organic matter that something could eat. Is there life in Europa? Or is there advanced life like blind crabs and tube worms and shrimp? We don't know. We may find out if life exists inside Europa within our lifetimes. Very exciting. You can see that in telescopes. In larger telescopes, Jupiter shows tremendous detail. And amateur astronomers can now record detail that only the world's greatest observatories could see just a few decades ago. I know a lot of members of the audience aren't even a few decades old, so that probably means nothing to you. If I say film, pictures taken on film, what's that, right? But some of us old timers remember fuzzy images. Now amateur astronomers can get great shots. The Hubble Space Telescope and the James Webb can show us much more detail on this gas giant, 11 times the size of the planet Earth. Some of these storms are the size of continents or the size of our whole planet. Even a small telescope, even a pair of binoculars. I have seen the 4 moons of Jupiter in a pair of binoculars. And look how far I have to zoom out to see the rest of the sky. Nearby, Jupiter and Cetus, the whale or sea monster. We have some of the stars of winter coming up in the east. I'll be talking more about these in January. The hunter, Orion, kind of looks like a hunter, holding a shield and an animal skin or a weapon. It's drawn different ways. So a club and the skin of an animal, generally. Sometimes this is his knee, sometimes it's his foot, Rigel. And all of you have heard of Betelgeuse, perhaps, the movie Betelgeuse. Betelgeuse is a red giant star. Just a couple of years back, it dimmed because of debris in front of it. It hadn't done that in my whole lifetime. It actually dimmed. It's one of the brightest stars in the sky, but it was not for a while. Alpha, brightest star in Orion, the hunter. And down below the belt of 3 stars, Alnitak, Alnilam, and Mintaka, the sword. In a pair of binoculars, you can see that the center star in the sword is a little fuzzy. It's not really just a star. It's a collection of stars having just been born from a cloud of gas, a nebula, glowing red from the hydrogen gas, the most abundant substance in the universe that makes up all visible matter, hydrogen, and then bright bluish young stars, hot blue-white stars, much hotter than the sun. Their light reflects from some of the gas that made these stars, making the gas look bluish. Dark lanes of dust that will someday collapse to form stars and planets. Dust also helps to create stars. So we have different kinds of nebulae here, dark, reflection, and emission. Look it up, check it out. That's one of the most famous nebulae in the sky, M number 42, M42 in Messier's catalog. Some of these stars are very far from us, 800 light years, 1900 light years, 900 light years. Betelgeuse, much closer, 497, 498. If you follow Orion's belt down or up, you can star hop. You can use that technique again. You can find other things in the sky, interesting things. Go up along the belt and you'll bypass the Hyades star cluster in Taurus. Sign of the zodiac, Taurus. What's Taurus? The bright red Aldebaran is his eye. And if you go past the Hyades star cluster, you come to a younger star cluster that looks like a little dipper. The 7 sisters, the Pleiades. I generally see 6 with my old eyes, 1, 2, 3, 4, 5, 6. Some of you might see 7 or 8, in binoculars, dozens. Relatively young, open cluster of stars, born together, traveling together. And recently it's been proposed that this bluish material, which I've always thought was gas that they were made from, might just be a coincidence. The cluster might just be passing through this dust area, and their light lights it up bluish because they're young bluish stars. This one, Pleione, spins so fast that it looks like a squashed egg if we could see it. Faster than Jupiter. 400 light years away. It's mind-boggling, isn't it? That the sky can really give you perspective on the scale of the universe in time and space. It's mind-expanding. Right nearby, the planet Uranus, which is generally not visible to the naked eye in our skies. You have to go to a very, very dark, clear sky to see Uranus with just your eye. Because of that, it had to be discovered by accident by telescope. Now, what if I zoom in? Is there any detail to Uranus? Let's see, we can see our field of view here, 5 degrees. Telescopic field of view is like less than a degree. Still hard to see anything. I zoom in, and it's a featureless greenish disk. This is also a gas giant planet, like Jupiter and Saturn and Neptune. And all 4 gas giant planets have rings. Did you know? The rings of Uranus are so dark, we generally can't see them in a telescope. The planets, Uranus, Jupiter, Saturn, all pass through the signs of the zodiac. Now, why are those signs important? All 13 of them. 13? I want to turn on the ecliptic, the path of the sun, the moon, and the planets, except for Mercury and Pluto. But if we just look at the major planets, they're all pretty much going through the sky in a straight line, past my sign, the sea goat. Don't make fun of me, I'm an old goat. The Aquarius, the water carrier, Pisces, the fishes, Aries, the ram, Taurus, the bull, the hunter, not a sign of the zodiac. Gemini, the twins. I say 13 because in my summer What's Up talks, I explain why we have 13 signs or 13 constellations that planets go through. The solar system is fairly flat, the major bodies. Not so for comets. They come in all different angles. Asteroids also fairly flat. But when we get out to the Kuiper Belt objects, those are all different angles too. Pretty cool. Can you see the ecliptic in the real sky? Of course not. Have to use our imaginations. Can you see the ecliptic? No. Can you see outlines? No. Can you see words that tell you what things are? No. It can be a real challenge. And that's why we do this talk for all of us every month to get ourselves oriented to the sky. We have other people who speak on other topics, anything from black holes to exploring the sky from Antarctica, to the latest research on galaxies that shows that modified gravity doesn't seem to explain what we're seeing. Gravity is very mysterious. So what we've just done is we've scanned the sky from north to south to east for the new stars that are rising. So if I were to do a summary, I would want to face south. I want to turn to my outlines again, the way you see things on a star chart, like the ones we sell, shameless plug, at our gift shop at UACNJ, Jenny Jump observatories. And what we want to do then is look for the planet Saturn before it disappears. Take a look in a telescope if you can. You can actually see the rings of Saturn. They are open, but in another less than 2 years, they will disappear as Earth goes around the sun. We pass through the plane of the rings and they will disappear because they're only about 30 feet thick, even though we're about 170,000 miles from end to end. Saturn's disk, about 9 times the size of Earth. What's 9 times 8,000? Roughly 70,000 miles. You can generally, even in a small telescope, you can generally find Titan Saturn's biggest moon, where methane exists in 3 forms at once: solid, liquid, and gas. So could it also be a place where there's life, but living at a very cold temperature? It's a speculation. We don't know. Some astronomers think we should look for life on Titan. Lots of exciting stuff happening, lots of new discoveries. This is a great time to be alive in the field of astronomy, because the discoveries come so fast that as soon as an astronomy book is written, it's obsolete. It's that quick. Once you're done with Saturn, you might want to look up higher in the south to find the Great Square, the Andromeda Galaxy, the fishes. Jupiter is a great object in telescopes now with its 4 moons. Look over for Cetus. Whoops. There it is. Cetus the serpent. Are you going to see pictures? No. You're going to see outlines? No. But they're a convenient mechanism for learning the sky. We're going to use the star hopping technique to find from Orion's belt the Bull and the 7 Sisters. And next month, we'll look in the opposite direction along the belt to find more things using star hopping. I'm going to conclude this portion of my talk by looking over to the east, far over, for the twins rising. Can you see them? The twins, Gemini, almost look like what they're supposed to be. Even if I remove the lines, there's one twin, there's the other. And to the naked eye, you don't need a lot of fancy equipment to get started in astronomy. You can see that Pollux looks more yellowish in color than Castor in the real sky. Stellarium does not show the colors as well as you would see them in the real sky. So don't get discouraged when looking at a star chart or stellarium or a computer program. Go out, look at the real thing. It's a lot more exciting, and it's a lot more interesting than having somebody like me blather at you for almost an hour about what's up in December. So I'm going to pause there and conclude my talk and come back to this by mentioning that you can get started for fairly inexpensive amount of money with binoculars. If you get bored with astronomy, you can always use them for bird watching, sports, spying on your neighbors. No, don't recommend that. You could then upgrade to telescopes. Now, some models of telescopes have come down in price, I'm pleased to say. When I was growing up, $200 was the minimum you needed to spend. Now, the Celestron Furscope is about $67 minimum. Dobsonian instruments, while a lot more expensive, give you much more light grasp for faint objects with their big mirrors, 8 or 10 inches. These are less expensive than telescopes like the kinds you see at the UACNJ observatories, catadioptric designs, Cassegrain designs. Those use special corrector lenses. They're a lot more expensive. To look at faint objects, I recommend Dobsonians. Very nice. Look it up. Space.com has some guides. Sky and Telescope, Astronomy Magazine. Before I show you those references, I just want to leave you one bit of news. I can't figure out why this asteroid 5457 Queens has an apostrophe in it. It's the only asteroid I found that has a possessive. So what is it? Does it belong to Queen, the rock group? Does it belong to a queen, like Queen Elizabeth? I don't know. This is the first asteroid pair, that is, an asteroid with a satellite, to have the satellite discovered by amateur astronomers, 5 of them, from Poland to Switzerland. And the picture that I'm showing you is not 5457 Queens. This is asteroid 152,830 Dinkins. But it gives you an idea of what the asteroid might look like. And that's how they found it, a dip in the light. They were measuring the light. It dipped for a while as the little satellite passed in front of the big one and eclipsed the light a little bit. They can actually detect this. Amateur astronomers' equipment is pretty sophisticated nowadays. Linked to computers, can do all kinds of analysis that we never could before. Got some homework for you, uacnij.org. Repeat after me, uacnij, uacnij, United Astronomy Clubs of New Jersey. That's an umbrella organization for a lot of organizations that have to do with astronomy in New Jersey, but also some from Pennsylvania and New York, some of our neighbors. Magazines in print, online, by subscription, and free. Sky and Telescope and Astronomy have vast areas of their websites that are free. Tremendous resources. They also have very nice centerfold star charts that you can take out of the magazine. The way I did it, I used needle nose pliers to pull the staples up. And then at the end, when I was done, I actually put the star charts back. What a geek, right? My wife will tell you, what a nerd. If you forget everything else I've said tonight, space.com is easy. Repeat after me, space.com. News, spaceflight, science, the search for life. You can get Stellarium for free to download. You can use it for free online. You can use it for free on your phone or a tablet. Same thing, and this runs on just about anything on a computer, any operating system. Same thing for Celestia, celestiaproject.space, but you can just look up Celestia, which lets you fly into space and go see what the rings of Saturn will look like from the only other place in the solar system where you can see the rings open, beside Earth. One of the moons of Saturn has an orbit tipped to the plane of the rings. It goes around every 80 days, about 79 days, actually, a little more. So half of that, every roughly 39 and something days, you pass right through the rings, they disappear, then they open up again. Cool place to put a hotel. And it's such a small asteroid that the gravity is practically nothing. So, quick review from go-astronomy.com. Check it out. Look for the planet Mercury early in the month. Also, fairly early is a great time to see nebulae and star clusters, like the Pleiades. There are other fainter clusters. Middle of the month, the Geminid meteor shower, or the Ursids. You can try for both if you have dark skies. Toward the end of the month, the shortest day of the year in New Jersey, in the Northern Hemisphere, the solstice, where the sun is lowest in the sky, December 22nd, and then December 27th, an absolutely terrible time to see faint objects, but don't be discouraged. It's a great time to go out, and you won't stumble because you got lots of light from the full moon. Set up your telescope, your binoculars, get out there, look, who cares if it's a full moon? The only way to learn is to get out there and practice, just like everything else. The sky's out there, it's free, it's for us amateur astronomers who like to help us lay people who are not professional astronomers to appreciate the sky. You can reach me here, my website with my free 3D models of planets, Astronomy in Motion. And at Mars at your fingertips, you can try the free demo HD 3D globe of Mars with links to videos made with my wife, the narrator, right there, who I haven't paid. And you can buy the 4K version with more features. So that's me. That's how you reach me. I want to say thank you. You've been a really great audience because you didn't interrupt me. You didn't ask questions. I'm hoping you will. And you can find us everywhere here, Discord, Facebook, online, Instagram, YouTube. Go look, Patreon. Go look for us. I'm going to pause here and thank Kim and Chris and Jeff and all of the people at UACNJ for making this series possible.
All right. Thank you so much, Lonnie. Thank you guys for joining us. And unlike what you thought, Lonnie, we do have a number of questions in chat. uh, Before we get into that, again, thank you, Lonnie. Thank you for everyone joining in. Do hit that those like and subscribe buttons here, because that does help us know that we are doing a good job, and we're actually pretty close to to actually 500 subscribers on YouTube. So that's exciting. All right, so our first online question is not that one because we fixed the audio issue. Uh, the first question is, what would the effect on Earth be by making the moon not rotationally locked to face the Earth?
It would be different two major ways. It would be close, much closer to us, and it would be rotating slowly. So it actually was rotating at its own rate initially when it formed, but it slowed down gradually over 4 billion years. 4 billion years is a long time. We know that the moon is leaving us by a few centimeters, a few fractions of an inch per year, maybe a few inches, might be more than one. So over billions of years, you add that up, it's going to be thousands of miles. But changing the rotation of the moon or different rotations of the moon would have very little effect. To change the rotation of the moon, you'd end up destroying the moon because it takes a lot of energy to do that. There was a science fiction series, Space 1999, where the moon was supposed to have been blown out of orbit. And that would be very hard to do. That's fiction as opposed to real science. So the short answer to your question is there wouldn't be much of a difference. It depends on how you would slow the moon down. You would practically have to destroy it or blow
What
it
if
up
you
to do
wanted to
that.
speed up the moon, like make it spin faster?
Wow, if you have, I guess if you put powerful rockets on one edge of the moon and spin it, uh, you would increase the angular momentum of the system. So what might happen then, the moon might recede from the Earth a lot quicker. So it might take, instead of billions of years, it might take only thousands of years. So we still wouldn't see much of a difference. A lot of things in astronomy happen very slowly.
All right, so uh, our next comment is that you should start the I actually adore astronomy organization. Go into
Okay.
competition for the little acronym there. IA. All right. So, next question is the US media has been saying there has been an X-class solar storm. What does that mean?
Oh, there has been or
There
there might
has been.
be. There has been X class. I don't know fully. I have heard that a very large solar storm like the Maunder, not the Maunder minimum. There was an opposite effect that actually was so powerful, sending out charged particles from the sun that when it hit the Earth, it disabled the entire telegraph system, which was all we had back in the late 19th century. Nowadays, we have a rather fragile electrical system. The wires aren't buried, they're all exposed. You know what happens during really bad windstorms. A very powerful solar event could knock out the entire world's electrical system, and we'd be back to 19th century technologies. So we really need to strengthen our electrical grid, don't we? Or perhaps make everything more independent with solar energy, nuclear energy, ammonia energy. That's a new proposal for running cars, fuel cells. But I am going to have to look up more information on X-class events because I don't know
All right.
fully.
So, I did a quick Google search. And keep in mind, this is a brief Google search. So, take information with a grain of salt and do trust but verify, shall we say. A where
Mhm.
it's actually a Class X solar flare, and flares are classified according to their strength. The smallest ones are B class, followed by C, M, and then X. X being the largest. And it's similar to the Richter scale for earthquake. And each letter represents a tenfold increase in energy output. So an X is 10 times an M, which is and which means it's 100 times a C class. So it is
Mhm.
one of the strongest solar flares.
So the consequence is we may see auroras, northern lights, much further south than usual. I actually did see aurora, northern lights at UACNJ observatories
Yeah,
many
that
years ago, which is
unfortunately was
unusual.
very before I was actually part of the organization, I think. Uh, the second part to the question is they said this means the northern lights are visible as far down as the Carolinas, and is that true? So,
Yes,
technically, yes. If everything was dark, if everything was a dark sky, it you would
yeah,
have
that's
a
that's a big
chance. However,
right. That's a big condition.
and I'm being told that I am very wrong. Uh, but there are factors you have to take into account, such as where are you as far as light pollution. So, a lot of times when we get media hype like that, we get inundated with a lot of, oh, can we see the aurora from UACNJ? And a lot of times, unfortunately, the answer is no. Just because you need above an 8 on the KP scale to even have a chance, and even then it's very difficult, if not very unlikely, between the weather, such as we had this last public season, and also the amount of light pollution, because even though we are one of the darkest sites in Jersey, it is not very dark as far as dark skies go. All right. So, our next online questions. Are you saying the best day or night for the Geminid shower is to try at 11:59 p.m. on December 14th?
Not precisely. Good question. Anytime around midnight, or generally, meteor showers are good after midnight, or the best time. But that does not mean that you won't see a really good opportunity to see meteors before that or after that. That's just an ideal
Yeah.
time. So if you don't want to stay up that late, you don't have to.
It's kind of like one of those nice bell graphs. It is the peak, the top part of that bell graph. It doesn't mean oh, it starts at this time, ends at this time. It's not like a solar eclipse where you have a solid stop time. You have a window. And honestly, you could see meteorites at any time of year.
Right. We could even simulate that in Stellarium.
I think you've had them randomly go across Stellarium a couple times for us.
Let's take a look here. Let's set the meteors to setting the scientific term, I call it ridiculous. Shooting stars. There we go. So you're not going to see this
Setting
in a
Stellarium to
meteor shower.
maximum particle effects.
Yeah, it's a ridiculous setting. Isn't that a setting in the Mel Brooks movie that was a parody of Star Wars? Ridiculous speed. Yeah, so that's somewhat what they look like, but you would never see a meteor storm, not even a meteor storm like that. Let's turn that down a little bit. There we go.
If
I did
if we
see
start seeing
one every.
something like that, we've had a fun comment go
Oh
by.
yeah, look at the old movie Day of the Triffids. That was how they depicted a meteor storm. Really nuts. I'm turning that off.
All right, our a good online comment actually. Uh, the M in Cassiopeia is for mother because Cassiopeia is Andromeda's mother.
Ah, Makes sense.
So that's a fun thing. All right. So next question is, uh, do we still have the mission to Europa going there, or did they put that on hold for focusing on Mars projects?
That great question. That's been back and forth for some time. And the last I heard, they had put it back for some time in the 2020s, not too far in the future. One problem is that the Mars return mission has gotten blown up in budget so much that it's taking away from everything else. So there's arguments right now in NASA to scale that back so that other missions can be funded with more priority. I would say we should make a mission to Europa a very high priority because then we would know for sure if life ever developed independently from life on Earth elsewhere in the solar system. And now we could do that on Mars. There are plans to dig in. They have dug into the Mars soil, and if you go down deep enough, you will find frozen water with the possibility of microbes. But it's going to be far more exciting to find more advanced life than microbes.
All right. Uh, Jumping ahead a bit here, someone said, "Wow, that sounds scary about the solar flare. When is that supposed to hit us?" Uh, it already happened. It really wasn't as impressive as they predicted, so no worries here. Uh, yeah, so we're cool. It was like a couple days ago, so didn't pan out nearly as strong as they were like hyping it up to be. Like those AAA video game titles, you're like hype, 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 and then you're like, oh.
Yeah, that happens a lot in news.
All right. So our next online question: will they ever add more things to the Messier catalog, or is that like done and set in stone now?
Yeah, that's been fixed for some time. I believe at 104, those are the brighter of the deep sky objects. I mean, now there's really no limit. You can go fainter and fainter to look for galaxies and nebulas or nebulae or star clusters. But that was set some time ago.
All right. And bouncing off of that question, does the Southern Hemisphere have a catalog like Messier's? And if they do, is it pronounced Messie's catalog?
I don't know the exact answer to that. I believe that the 104 objects in the catalog span most of the skies, including some southern.
I just watched both of the guys here just face palm at that joke, so
Uh-oh.
so that's always a good sign. All right. You were mentioning why we do this talk and because it changes every month. It's also the same reason why someone has suggested making monthly sets of flashcards for observers who operate the telescopes on public night. It's a cheat sheet reference for what's up. No one has actually made them so far, though. So, all right. Uh, Actually, I had a question for you. Has You always put your little email address there at the end. Has anyone actually reached out to you from these talks?
Once in a while,
Oh,
yeah, you're certainly welcome to, or you can go on the website that also has links to my email and other things. There's artwork, some videos, a lot of fun stuff.
uh,
But I will answer every message.
right. And even if, for example, you don't catch us here live, you can always go back, check out our videos. We do keep them archived on YouTube. You can always comment on those there. And when I see them and it's a question, I do try and answer them and also keep it free from weird spam bots trying to sell people things. So I've deleted a number of those lately. No spam bots allowed.
Good.
All right. So One of our online viewers says there are currently 110 objects listed in the Messier catalog.
110. Okay.
So,
That's a lot. Try finding as many as you can in one night. All you have to do is stay up all night.
yeah, I forget. Was there a time of year that's supposed to happen where they have the Messier marathons, or is that like all year round?
I would not know the specific day.
Yeah, I'd have to ask a couple of our astronomers I know have done that. I'll have to ask them next time I see them. Like Bill Murray, or I was told
Yeah, we have
winter. Winter is the answer.
yeah, we have amateurs who know a lot more about what's up there than professional astronomers.
Well, astronomy is a big topic, and so there happens to be, when you do it professionally, you tend to narrow in on a very, like a niche. So,
Hmm.
right. So I'm gonna put out a last call for any questions online and give you guys a couple minutes, just because stream delay is a thing. Once again, I want to thank everyone for joining us. Thank you again, Lonnie, for another great talk. Do check us out on our website, uacnj.org, and also our social media, Facebook, Instagram, our Discord channel. And as always, thank you to our Patreon subscribers. It's always very helpful there. It looks like
Well,
I'm getting a lot of people say goodbye. So it looks like we actually have most of our questions answered.
very good. Well,
So,
I want to thank Kim and Chris and Jeff and everybody behind the scenes and UACNJ for making this possible. And thanks everybody out there.
all right. So until next time, have a good night.